Concrete aggregates. Introduction. Consists of sand, gravel and stones, either crushed or uncrushed or a suitable combination of them. Should be strong, hard, dense, durable and free from injurious amount of alkalis etc. Should avoid containing harmful material as it causes corrosion of the reinforcement. Aggregates categories. Concrete aggregates are subdivided into two categories, based upon size: coarse aggregates and fine aggregates. Coarse aggregates contain gravel and crushed stone, typical size between 9.5 to 37.5 mm. Sand or crushed stone are most common types of fine aggregates, typical size between 4.75 mm to 0.1 mm. Fine aggregate content generally used in construction are 35 to 45% by mass or volume of total aggregate. Fine aggregates. Sand is mainly used as a fine aggregate. Derived from river beds, check on silt and clay content, size less than 0.1 mm, maximum permissible limit of 7% is allowed at sites. Sand undergoes buckling. In buckling, the volume of sand increase due to the presence of water. Ensure avoidance of buckling and proper content of sand in the concrete mix. Fine aggregates, sand. Sand is divided into 4 zones, Zone 1 to Zone 4. Zone 1. Sand being very coarse. Zone 4. Sand being very fine. IS Code. 383 recommends usage of Zones 1 to Zone 3 sand for structural concrete works. After sieve analysis, the percentage passing 600 micron sieve is determined and based on that zone is established. Grading limits of fine aggregates. Grading limit of sand can be decided after sieve analysis. After sieve analysis, find the percentage passing of sand. In sieve analysis 10 4.75 2.36 1.18 0.6 0.30 0.15 mm size sieves are used. Zone 1 to 4 are decided based on percentage passing on 600 micron sieve. 15 to 34% passing Zone 1. 35 to 95% passing Zone 2. 60 to 79% passing Zone 3. 80 to 100% passing Zone 4. Fineness Modulus. Fineness modulus is a term used as an index to the fineness or coarseness of aggregate. This is the summation of cumulative percentage of materials retained on the standard sieves divided by 100. Fineness modulus of sand should not be less than 2.3 and not more than 3.1. Coarse aggregates. Category consists mainly of quarry stones, gravels or uncrushed stones. Size of coarse aggregates are greater than 5 mm. Coarse aggregate characteristics. Flaky aggregates. One dimension much lesser than other two. Elongated aggregates. One dimension much more than other two. Angular aggregates. Partly shaped, having angular edges. Rounded aggregates. Fully worn out by water. Coarse aggregate characteristics. Angular, elongated and rough aggregates will give high strength but low workability. Rounded and smooth aggregates gives less strength but high workability. Aggregates gradation. The voids between the largest fine aggregate particles are filled by smaller fine aggregate particles, the voids between the smaller fine aggregate particles by still smaller particles, and so on. Finally, the voids between the finest grains are filled with cement. You can see from this that the better the aggregate is graded, that is, the better the distribution of particles sizes, the more solidly all voids will be filled, and the denser and stronger will be the concrete. If there is no gradation, therefore more void spaces, more cement paste required, which increases the cost for concrete. Mechanical properties of coarse aggregate. Crushing value. Relative measure of resistance to crushing under a gradually applied compressive load. Abrasion value. The percentage wear of the aggregates due to rubbing with steel balls. Impact value. Is resistance to sudden impact or shock. Classification of aggregates by sieve analysis. Sieve analysis ensures perfect aggregates mix. Coarse aggregates range passing through opening of 90 mm and retained on 4.75 mm. 63 mm to 90 mm we usually called metal. 20 mm we called kapaki in Gujarati, and in North India we called GT according to the size. 10 to 6 mm commonly called grit. Fine aggregate passing through sieve of 4.75 mm is called sand. Percentage of aggregate used in concrete. 60% coarse aggregate and 40% fine aggregate are used in concrete according to the total volume of the aggregate used. Storage of aggregates. Should be stored on hard, firm ground. Ground should be having sufficient slope to provide adequate drainage of water. Prevent intrusion of foreign matter. Aggregate becoming wet shall not be used for at least 24 hours. Store to obtain segregation based on type, grade and source. In hot areas, provide shelter to control temperature for aggregates.